Welcome back to Made of Wires, where we are decompiling Castlevania Symphony of the Night. Go to soten.z.dev to learn more. As the banner at the beginning showed, I'll be at Game On Expo April 5th at 7 p.m. and I have some fun stuff, I think, to show off. I'll give you a little preview of something that I've been working on, and I hope to do a little bit more with it before Game On Expo. If I could figure out how to manage my windows, that might work out well. So at Game On Expo, we're going to be talking about decompiling Castlevania Symphony of the Night, kind of what I've done. I've been working on the project almost a year now. I think April is when I submitted my first PR last year. And I've learned some things along the way, obviously. I don't know everything there is to know about decompilation. I don't know everything there is to know about Symphony of the Night. But I think between streaming and some of the things I do know, for a gaming audience, I think it should be a pretty good talk. Let me, I'm trying to get the DuckStation set up. So one of the things that makes decompiling useful is the ability to mod the game, and my controller is not registering, so let's try that again. There we go. I want to get so most of us should be familiar with stage 0, or sorry, final stage, ST0, which is where you start the game as Richter. If you've ever played Symphony of the Night, which I assume most of the people watching this channel have, you should be familiar with your initial fight with Dracula, which seems like an odd way to start the game. It kind of gives you a preview of what's to come. And so when you're walking up the stairs to Dracula's chamber, there's a huge 3D clock tower, and that's something that differentiates the Symphony of the Night version of this area from the Rondo of Blood version of this area. Howdy, Project Omega, good to have you back. Roman, good to have you back too. Nice to see friendly faces back in chat. So it's what everybody's going to experience. Lion Guru, 5 months, thank you very much. Really appreciate it. Well, anyway, so one of the things that decompilation makes relatively straightforward is adding and modifying the game, and that's not my primary purpose. I like the challenge of decompilation. I decompile for decompilation's sake, and because I like the game, I want to learn more about some of the implementation details. But modding does become more straightforward once we have decompiled. And so I wanted to show off some things that are, I wouldn't say trivial to do. I'm not a graphics programmer or 3D programmer by any stretch of the imagination. I've done some in the past. But going from having not looked at this clock tower code much to this change was something that didn't take very long. So instead of the clock tower walking up the stairs, you get a nice made up of wires logo. The frame is 3D. The letters are not 3D yet, but they will be, and they will be spinning. So that's something I started working on last night, and we'll get done before the talk in April. All right, so we've been working on Doppleganger 40 and Doppleganger 10. I have a bunch of changes. There were a couple changes kind of in flight that I have out for PR. I was working on this last night, and so I haven't looked at PRs or responded to those. So I don't think any of the Doppleganger changes we made on the stream yet are in. So I think we'll go back to just what we've been working on over the last couple days. And it's this door function. One of the things that I was struggling with basically since pulling this up was this division. I knew that this was a division, and so what I had started to do, and now I don't think it's necessarily useful, when you're doing division, and let's see what the PlayStation version looks like. I haven't seen the object diff support. I do want to look at it. So let me look at that. The other thing that I really want to do is let's look at options. Is it like in a profile? No, that's not setting. Oh, settings. All right, let's look at that. See what. Let me save this. Oh, there it is already. Wow. Okay, so this is pretty interesting. So this is showing how RO data is getting generated, and can I can even expand that. That's nice as well. And I'll need to figure out. I haven't used object diff. Got it. Okay, so let's try that. All right, so we can. That's actually a much cleaner diff. There is some. So my guess is that there's not PSP support yet for some of the other instructions. I'm guessing those are SEH instructions. I'll have to take a look at it a little more. I won't do it on the stream, but it's always nice that new things are added. All right, so what I was saying before was, and I don't really care about the symbol name at the moment, but I will we'll get back to it later. Did you work on that, Romy? So what I was, oh, well, I'm waiting for, okay. Oh, well, thank you for pointing it out, and I will take a look at it. I tend to get stuck in my my primitive tooling, and like I'll figure out some way to do things, and then just kind of often have a hard wall in my head for getting past that. So I always appreciate people bringing up things, and then I'll reject them as a curmudgeon, get off my lawn, until I see the light, and then I'll become a huge advocate if that comes to be. So one of the things I was looking at yesterday and the day before was this division, and I knew it was either a division or a mod because the instructions that get generated are a bunch of shifts. You have your multiply, there's a check for sign changes and things like that. And it's code that basically a human wouldn't write. And that's how division is done on these systems that don't have, especially for PS1 and PSP, they don't have floating point math coprocessors, so they're doing all integer division. So you often get a lot of these magic numbers. And some of the magic numbers you can use to look up tables, and there's tables that show you what these are. So the primes are usually a good value to throw in here because prime numbers are all going to have unique magic numbers. And you can find basically every compiler will have a list of these. And it's just a way to approximate an integer division using multiplication. And then with some additional checks, you can get the actual answer. And so this looked like one of those scenarios, but I was having trouble figuring out what it was. And what tipped me off? I think it was... I think it was the shifts. So offset X ends up being not a, well, the value here at unknown 80, and I should go change that. The value at unknown 80 ends up not being a 32-bit, a typical 32-bit integer, but it's a Soton fixed fractional type real number. And so when we divide that by another fixed number, that this fixed number representation is one. What is that? The fixed one should be hex 1000. No, 10,000. That. Yeah, there we go. So when I saw that this was a number of this size, this tells me basically that it's a fixed value. We're not gonna, we don't have any integer multiplication really in this range, and so we can use a fix instead. So some of those I find tricky, especially when they're random numbers, like the one I showed you with 3 or 7. Those are a little easier because they're Googleable. When you get something like 8,000, or sorry, this is the top 8 bits are 8,000, and the bottom 16 bits is just 1. That becomes a much more difficult number to Google. All right, let's keep going. So I'm looking at the PSP version primarily, and just trying to refresh my memory. We have a bunch of register and stack issues at the moment, and I'm going to ignore most of those and look for things like this where we have instruction differences. And so this is saying that there ends up being, we're storing a half word, so a 16-bit value, but it looks like this is being converted to a 32-bit value. And the I high is 16-bit, so this 16-bit value needs to be converted to do the addition, and then, or maybe the subtraction, before it's stored in to this position Y. So it looks like position Y is a 32-bit value, even though, oh, not X. No, that doesn't work either. So why don't we have a sign extension there? Maybe it's specifically cast beforehand, or cast as unsigned? No, unsigned wouldn't make sense, because then you need a mask. So let's try casting it as assigned and see what happens. I'm a little confused as to why the sign extension is happening twice. We see something similar above as well. I was going to say it's possible that this is being loaded as a word, but we see it's being loaded as a half, so just 16 bits. Let's try position X as a 32-bit. So we get the sign extension there. The store word, and maybe I shouldn't worry about it above, is because this is getting pushed back to the stack. So I'm going to change position Y as well. And I think that's, yeah, so we get the same instructions, but then we get an additional instruction to push it back to the stack as we get rid of other variables that are not necessary. Those should go away. 104. It's possible that offset X is as well, but again, this is loading a word from the stack as opposed to loading it from a register, so I'm not super concerned. I guess that could be the next thing that I do is just look at getting rid of variables. We have a big section down here that's full of mods and other things like that that is kind of ripe for cleaning up, and there's likely a bunch of things here that should be the same variable but are being used as separate variables. So let's see what that looks like. So I think what I'll do is maybe make this varv03 and all the varv zeros. Make those J as a secondary index. And then that should get rid of a bunch of variables. So let's start with that. And go from I want to find this 227 as well. So when this gets stored back to G, it's coming back just as whatever this value is. So this is something that looks somewhat similar. I don't think that this is actually checking for less than 0 and then adding, it probably is like a mod 255. So this, we're calculating an angle based on this J value. So I believe that this is the color wheel rotation that's behind the vault when you're going into the Doppelganger room. And so the only thing really that it cares about is that it's within this 0 to 255 range. I do want to look at what M2C thinks is happening here. So yeah, they generate this slightly differently. Let's find the G specifically. So they're doing the shift by 8 first. So I think there is a shift by 8, and then like a mod 255. Let's try that and see what that ends up with. Getting back to some of your comments, roaming. Soten does not yet run on Vulkan. It's actually really simple what I want to do, but the streaming intro that I usually use has the rotating made up of wires logo, kind of a Z rotation. Rotating along the x-axis, along a circle that's along the Z, parallel to the Z-axis. And so it's pretty simple math. It's just calculating where each vertex is in relation to the where y and x coordinates meet. Fortunately, the logo is at situated at 0, so there's no translation even necessary. So calculating that, calculating the angle, modifying the angle, and then calculating the new y and z offsets for that vertex. Not terribly complicated, just pretty basic geometry. But then, packing it back into the GTE functions. Those work a little different than I'm used to. So it's been many, many years, but I did some OpenGL work a long, long time ago. And what I remember there was basically translating to where I wanted to be. And then, so yeah, I think that mod basically did everything that I wanted. Maybe a little different. It might be 256. Looks a little better. And I think we get rid of the shift down below, and I think this is just inlined. So not quite perfect. There might be a shift that's missing. Divided by 256, it looks like. It's a little odd. I can't remember what, if... I'm assuming the R means the sign function's in radians. I don't recall. Let's see if my inline ref.pdf can tell me. No, it's not there. Let's see. I have these docs open somewhere. Okay, so we'd have to look at what this value is at 104. My guess is that it's some value between 0 and it would have to be a multiple of 255. Oh, where is this doc? libref is what I want. Okay, so the return value here is a little funny. Let me see if I can share this in a meaningful way. I don't want to do that. Let's see. So our sign returns kind of an odd format. So 4096 happens to be 1 shifted over 12 times, I believe. Yes. Which is the PlayStation fixed point format. So there's 24 bits of integer, 12 bits of fraction. That 1.0 is the same as 2 pi, which should be radians, right? No. Radians is... Okay, so this is, yeah, this times pi would give you 360. So when we're rotating here, or when we're calculating this sine value, this, we're getting this this fractional value between 0 and 4096, and then we're multiplying it by this global. Let's see what this global is. And oh, good, we have this. It's BSS, so it's nothing. So it's going to start out as 0, and it's actually set up above here based on another value, which is right next to it, which is also 0. That gets incremented by 16 as it goes around. So 4096 divided by 256 is 16 as well. So basically we're kind of moving increments of 16 out of the 256 color range of each of these channels. That's how I'm reading it. Could be wrong, but I'm going to stick with that for now. So I think all of these are basically going to follow that same format. And so we can basically replace all of these with the same thing. And that should get rid of a ton of these variables that we have. These are kind of similar, where we are doing some additional fixed point math in here as well. Looks like I have missing some. There we go. Enough. .222 is where it's failing. Looks like I'm missing a. Or I have too many parens. There we go. So let's go up here. And so now this is falling in place too. Again, we have the moves. I believe this is because things. Let's move here. I'm not quite sure yet why this is resulting in a move. As opposed to writing directly to the register. We'll figure that out later. I'm mostly concerned that all the other instructions are correct. Registers I'm not too concerned about, but this seems like the pattern that we'll have going forward. The times 16 here may be a shift by 4 to the left. So basically we need to go through and kind of do all of this for each of these. So we're going to take j equals I plus 10, and then mod 20, sorry, 32. And then this becomes j. And I got rid of that temp. Actually, all of this is just j. Also a little bit confusing. And the same thing here where we have another fixed value. Basically, these are all look identical. The only difference is what we're adding and then what the mod is up above. And then this is going to be assigned to B0 and the same division. And then we'll keep going. Oh, I do want to see, take a moment to see what this looks like on the PlayStation side and if it's converging the same way. It's getting a little further. Let's see what those instructions look like over here. Instructions are mostly fine. There is an additional read of this 5e, this 5EC value. So it looks like that is getting cached somehow. That isn't happening yet. The way that the PSP instructions are looking, though, there is a read of that global for each of these instructions. So my hope is that as we get closer, that those are going to work out. So I'm just going to work through these, and if I see anything that is that seems otherwise off or funny, I'll call it out. this, I think, was kind of a weak attempt at figuring this out to begin with. So I'm pretty sure that this is all just going to consolidate down to J, and then basically the same. The hardest part about these, to me, is a lot of the variables are interleaved. And so like in this case, tempv1_6 was way above where it's being used. I don't know the meaning behind a lot of this either. And I think that's something that I don't talk a lot about on the stream, primarily because while it's interesting, it's not the main focus for me. The main focus is just getting back to the C code. I know that I'm not going to understand everything, and it often takes time just documenting. So this one is 11. It looks like it's mod 256. This one is supposed to be a mod. But that is not right, so let's try mod 16. Possibly mod 32. 16 looks fine. And yeah, this G value is all the way down here. One of the things I wanted to do, and this code may actually be helpful in doing that, I ended up texturing that made up of wires logo just with the clock tower textures, because that's what the existing code did, and basically I was just changing the geometry. And I think we'll look at that a little bit too, how that works and how it would have been, or it is difficult for modders to mod a bunch of things in the game because it's just in code, and we don't have like external models that are being loaded in that you can just replace. But there is kind of a scripting language that at least for the clock tower is used, but it doesn't seem to be generic. It seems to be just implemented for that, which is kind of a shame. But I'll show you how that's done when I get closer to finishing this off. And I think that's something that probably would have been hard to figure out without a decomp project, like looking at the machine code, because there basically is a small interpreter that is doing that. I missed my addition somewhere. I'm just going to keep going and fake it till I make it, and look at the other. So these all seem to be +5. I'm gonna try. No, I have 11 already. Oh, do I have it? Is that J? Is that J? I have it. The mod there is wrong though. Should be mod 30. No, 20. So this is 26, mod 27? That's odd. I'm sure this is wrong, but I will figure it out. when I get there. A language to do what? A language to draw the clock tower. A language just for drawing clock towers. If you think that's funny, it's kind of sad. I'll show you in just a second. After this ad. Stick around. How's that for a... I don't know what. How's that for a something? So we're grabbing a reference to this and then assigning it. I don't think that's necessary. I think we can just assign it. We do need to assign the val. And temp v1 underscore 8. I blew that away along the way. So who knows what that was, but we'll figure that out as well. If you're seeing an ad now, or if you're not seeing an ad now, thank you very much for subscribing. I really appreciate all the people who have supported the channel and show up. It really is encouraging to be able to talk with everybody who shows up in chat. I have a lot of fun doing it. So I'm going to screw around with this a little bit and try to figure out what this should have been. It looks like 11 is correct. Here's our 11 there. So we still have a bunch of moves and stuff. I'm going to take this over again. And we'll get the PlayStation version. Getting a little closer there. We were at 87.38. We got a whole 0.2% with a lot of work. That's kind of sad. I probably could go back and get rid of these casts, but I'm not going to do that. I am going to figure out what this temp v1 underscore 8 is supposed to be. And I can't do it here. I need to go back over to the PlayStation. All right, 3 seconds, and then we'll get back to it. Temp v1 underscore 8 is this. Var s0 underscore 4 is I. So basically, we're just taking the same thing and doing a plus equals 32. All right, so I mentioned that there is a clock tower scripting language. And let's look at that. You can see my messy code for drawing the logo. So I showed at the beginning of the stream replacing the clock tower. Let's see if I still have all that up. I don't know if you're on then, Mozilla, but this is for a demo that I wanted to do later on, but instead of a clock tower, we have made up Wires logo, like should have been in the game originally. The frame is 3D. The letters are not yet because I haven't finished those, and they're not textured the way that I want, but they're there, and they're in place of the clock tower. So kind of a fun thing for me, maybe not for you. So I drew my ASCII art to get all my coordinates in place. And what's interesting is, I'm doing this just by hand, laying out all my coordinates painfully. It's completely possible that there was a generator originally done for this. I don't know if that's the case. But what the clock tower data looks like originally is a little bit different. Soten is extremely conservative with its points. So if you look at like my logo, the front face here ends up being 4 polygons. Basically, you have trapezoids that make up each segment in the front. And so each of those trapezoids is going to share 2 points with the adjacent trapezoid. And because I'm dumb and can't think like that very easily, I just duplicate those points in my arrays and have these gigantic arrays with duplicated points. The Soten developers are smarter than me. This is, I think, a very Japanese way of doing things. They do not waste bytes on extra points. A point is only specified once in here. And so I think these top ones are the like the pyramid shapes. So you there's an extra point in here. This is probably one of the pyramids here with 5 points. So you have exactly 5 points. And then down below, this is the one for the pyramids at the top. But I annotated this one. There's actually 2 different kind of bytecode scripts for these. One is for the top pyramid section, and this bottom one is for the squared off faces, the clock itself, and then the base of the clock. The first byte is used basically to indicate that the next byte is for determining what vector table index should be used. For the vector table is down here. I have my own array in this vector table, and I'm putting all my points in there, so mine is index 9. And so I only have to specify it once. I specify the marker for noting that there's a vector table change coming, and then the index there. And then the next 4 values are what vectors to take for each of the points of the quad that's going to be drawn. And in this case, they're quads. The one up above actually might be triangles, but for the base, it's quads. And the way that these are specified is kind of funny as well. The first one is what index in the texture table you want to use, and then the next 4. And you can see the order is 0, 1, 3, 2. That threw me off to begin with as well, so I was going clockwise around each of my polygons to draw them. But that's, of course, that's not the order. You have to go, if you're going top to bottom, go top left, top right, bottom left, bottom right, and then some priority. And the priority is just where in the drawing plane that polygon is going to be drawn. So if there are things that clip for whatever reason, which one is going to take priority higher is higher priority. And so, writing those out is pretty easy. The biggest thing for me is it decouples each of those vertexes from how they end up being laid out for geometry, which is kind of a pain. And so I'm kind of ignoring the ability to compress all those things. I could compress this because I have relatively few points, but it's harder to reason about. And we can go down to the code that does that. And the code is pretty simple. I say it's a little script or whatever, but it's just everything's interpreted as bytes, and depending on their position and what their value is. So if the byte that you're reading is, there's one more special byte, which is the FF byte, which says the script is done. So we come through looking for that special FF byte. If we have the vector table marker, we're going to read that, and then from that point forward, we're taking chunks of 5 bytes, which are the the texture index, sorry, 6 bytes, texture index, the 4 vertexes of the quad, and then the priority, and then you continue on until you get to the end. Yes, it's pretty interesting. It would be interesting to see. The one thing, so this is actually a nicer formatted version. Let me see if I can find what's in GitHub right now. I don't think anybody has looked at this except to identify it as the clock tower function. 3A-E08. So if you did want to put other geometry in there, though, so this is what it looks like currently. And it's a lot of times we'll see arrays of 16-bit values or 8-bit values, and it's because somebody hasn't put any structure around them yet. In this case, though, they are just byte arrays, and the structure comes from meaning of each of the bytes and how the subsequent bytes are interpreted. And really the only way, actually it's this section down here. The only way to know that is by reading the code and learning. It's a little strange. I haven't looked at the save room geometry or like the chapel geometry. I'm trying to think of where else there are 3D objects. Any of the doors, I guess. Red door is a little different, but this is baked into code. It's not data. It's not in a separate file that's loaded or anything like that. So whatever space this takes up in memory, the best that you might be able to do if you wanted to change that clock tower is modify this array of vector pointers to something that's in BSS, for example, where you might have a lot of space to draw the geometry for it. But you'd still be limited to what textures you can choose, and that texture table is up here. So it's I don't know. It's a little unfortunate, I think, that all of this is so baked in. But with the source code, my like round trip for testing it is 10 or 15 seconds to make a change and then check it. So kind of a nice thing. Let's get back to what we were doing. I probably will so obviously the logo stuff, that's all in a separate branch. The comments I probably will check in separately, and I think I'm going to add macros to specify the various functions, like select vector table macro and block script, things like that, so that it becomes easier to modify that in the future. Back to this. So let's look at our stack and how that's doing. Our stack now actually is too small. It was much too large earlier. Now we're only using 40 bytes versus, 40 hex, 64 bytes versus 80. So we have to add more variables. I'm going to go through and try to find instructions that are missing or out of order. Here, so we're going to get a lot of differences between stack pointer, just because that's different in size now. And registers are going to be wrong as well. So here there is a load from 3C. So storing a value to 3C, actually the value in V1. So somehow this prim index is getting pushed to the stack and then being read back from the stack. Again, is that what's happening? No, I think our S7 value. We do need prim index, we can't get rid of it. I'm gonna peek at the decomp and see what. The decomp isn't doing anything, or the M2C version is not doing anything different. Yeah, I think it's just that prim index is spilling to the stack. I do want to check the order of these. Priority draw mode. This is the last prim. So all of this looks correct. So this is a little different. I have this outside of this branch, and there was a reason for that. This is a. I really don't. I'm not gonna get rid of this else. Just don't like how that looks. We do need to return, however, and there is a. This break should be at the end. Actually, it's fine either way. These are going to coalesce into the same thing. So until I get this spilling, I'm not going to get rid of these, or I'm not going to get those instructions. And this kind of the same thing down here. Those instructions aren't going to reappear until we figure out what variables are missing. Yeah, and so I had this down here originally, and that fits better with the code gen. I'm not sure why M2C thinks otherwise. All these are just register differences. Here we're missing a sign extension on 230. Pretty far. All of these are inlined, and I'm a little surprised that it didn't show up earlier. I'm gonna get rid of the casts here. Oh, what did I miss here on line 172? Again, we're loading something off of the stack. 40 is like the self pointer. That is arg0. We're loading the value at offset 6, which is y. So it looks like we're storing off value y into S5. And the sign extension suggests that this is a 32-bit. So let's look at what pos y is. Pos y is already 32-bit. Let's try to reuse that. If it doesn't work out, we can make a new variable. Pos X is actually being assigned as well, but that's coming second, which happens. I don't necessarily like it, but that's what's happening. And then I think these are being used down here. Hurts my brain when they're out of order. It looks like the add is after the shift. Oh, Roaming, you missed possibly. I went over how the clock tower scripting works, which is somewhat interesting. So yeah, these were just out of order. So I was showing how the clock tower basically has two different interpreters for scripts for generating the geometry, and how basically all the vertexes are compressed into arrays, and then a script comes through and provides indexes into those arrays for each of the points of geometry, which is pretty efficient, but more yeah, it's how they're creating the meshes, and it's I don't know. There's not enough evidence to say that it was generated. Like if they had a mesh, I think 3D was it 3D Studio Max that was shipped with the SDK originally, and maybe that could generate these arrays. I don't know. But anyway, there is this little thing that comes, basically a little loop that interprets this byte stream to choose the right vector table, choose the right texture index, and things like that. Yeah, that's true. Yeah, like have some OBJ file and then generate that. That would be a relatively trivial program to write. Give that to the intern to. I just think it's kind of crazy that you would generate, and I guess everything is about efficiency. So there's a subtraction here that I'm missing. Load immediate EO. EO is 224. What is that? There we go. So these were just out of order. Does this one change? So that one looks fine as well. So yeah, these are coming along a little slower than I had hoped, but yeah, fine. I'm assuming this is going to be the same thing, 224 minus the result. So we have a +1 that's missing. S2 is being used up above. S2 looks like our I, so we might be incrementing I as we're going through. Oh, maybe this is updating of RS1. So these conversions are switching between the PlayStation native format, fixed point format, and I added macros for these, but I find them relatively cumbersome to use, so I haven't been using them. Now we have a move here that I'm hoping gets worked out. Sometimes this happens. V0 and V1 are used for return values. Sometimes if there is no return value, for example, this function is void, they will be used internally as additional registers. Occasionally you'll see them get swapped like this on MetroWorks, and I'm not sure why, but it happens. And often when the other registers get worked out, then those get fixed. There's some... So these are stack pointer... no, actually these are being loaded into the wrong things. Looks like the order is different. So 32, 26, 30, 24, 30, 24. Again, kind of odd that Y is coming first, but who am I to argue? As long as the registers are the only differences, I'll keep going. Same with stack. Again, one of these moves. This is actually being moved. V1 is being moved into a variable, so this may be one of the variables that's missing on line 201. But we're actually going right into the variable, whereas this is going into this temporary register V1 and then being moved into the variable register. I'm not sure why. We're getting closer. Unfortunately, I think what's going to happen soon is I'm going to have to start debugging variables and ordering and things like that, and that's not a lot of fun. But I'm not seeing a lot of instruction differences. The PlayStation side should be more favorable, and it should be, yeah, 94% now on the PlayStation side. So getting very close there. We should be able to see what kind of things are different. If there's instruction differences still on the PlayStation side, I know that there's code that's wrong. There is, so we have a variable size that looks like it's wrong on 103. Prim should be a pointer. Oh, these are just happening out of order. I'm going to get rid of these casts. So let's move that up. I would have assumed that this would have shown up there. Position X and Y are being loaded as unsigned. That's a little strange as well. I don't know how that's going to affect the PSP. Let's look. I want to see 90.93. Did that reordering change this at all? Took it down quite a bit. So I don't think that's the case. I think the place GCC is not wrong, but I think it's generating the wrong thing. I'm gonna try changing those variables to unsigned. Because I share those elsewhere, it might be kind of a deal to mess with them. So let's see. That's up on line 101. So we're loading signed 16-bit values. We have to sign extend them into 32 bits. If I change these to unsigned, it actually doesn't change much. It doesn't change anything. But does not help here either. It's almost as if these loads are being cast as unsigned 16, which again shouldn't affect. I don't think will affect the PSP. Oh, it does. It adds a bunch of masks. Yuck. But if position X and Y were also unsigned, then those masks wouldn't be necessary. Right? Nope. So I'm not sure what's going on to cause the... the unsigned loads here. But we're getting close. There are... Oh, what did I do? Broke it. There are SEH instructions that are missing down here. So, does that mean position Y is assigned 16? Yes. And what about position X if we make that sign 16? So that's an improvement overall. Okay, let's look at... much worse, though, on the PlayStation side. It's definitely possible that there's a second set of variables for position X and position Y. Often I call those offset X and offset Y. We'll have to look at that. I'm going to go through... We do have offset X and offset Y already. I'm going to go through and clean up all these variables. And there are a lot of them. So do we have any temps left? We don't. Do we have any vars left? We do have one. I think I'm going to call this J. We'll see if we can reuse that variable. PSP is so picky about variables that it is Kind of unfortunate. It does limit what you can do. It's a little yeah, Final Fight CD is awesome. I had a friend who had a Super Nintendo, and we played Final Fight like nobody's business on the Super Nintendo. And then the Sega CD version came out, and it had all the characters, and you could play 2-player. It was the best. Oh, I'm gonna have to watch me die on stream. There we go. Here's my copy of Final Fight. This is I'm trying to think if I had. This is my original box. It's definitely my original CD and manual. I think I might have gotten the box later, though. Can't remember. It might be my original box. But yeah, Final Fight CD is incredible. Incredible. Yeah, the music is awesome. It is, for the Sega CD, I think it's probably the closest thing to a perfect port. I have the one complete collection I have is a complete Sega CD collection, plus more. That would be awesome, actually. So I've been talking about this actually recently on the stream. I don't know how you're intending to port it. I actually don't know a lot about. Was it CPS1 hardware originally? Let's see. Was that, yeah, Motorola 68K at 10 megahertz. So that should be completely possible. I don't know what else. What else CPS1 had on it that that would prevent it. So kind of going back a bit, there's been requests to do kind of streams specifically about Splat, and I wanted to start a project from scratch to see how much I knew about Splat rather than just using it in an existing project. And so I pulled out can't reach as far as I thought. My SNK Arcade Classics. And what I was hoping for, and I think might exist on that disk, is a basically SNK specific 68K or Neo Geo emulator, and decompiling SNK's own Neo Geo emulator would be fun. And there's the Wii version, PSP version of that as well. So it's running on not the Wii, but the PSP. We have 3 architectures that it's running on, and it's the PSP at least is much more meager hardware than the PS2. Oh, that's interesting. Yeah, I don't know. I know a reasonable amount about 68K because I spent a long time looking at different Sega CD internals, and I had a project and I really would like to finish it. But basically, a long time ago, somebody made these awesome posters of Atari games where they were printing out disassembled Atari games, basically a full listing, and then because the data is just inline, identifying sprites and like putting them in line in the code listing. And so I was doing that for Sega Genesis and Sega CD games as well. And it's you get a much larger data, much bigger poster, but it was pretty cool. Yeah, I don't know. A lot. I did a reasonable amount of 68K programming 20 plus years ago. And it's nice because it's fixed width instructions, very easy to understand. There's a lot of documentation for it. I have seen that. I have seen that exist. That also may be in my future. Looking at that as well. So I'm going through now and finding different things. So I have a feeling that this position X and position Y may. I have offset X here. I thought that this potentially is a different variable. I'm actually going to take create a new variable for offset X that's assigned 16. Or sorry, offset Y. And use that here instead. And that gives me the additional SEH instructions that I was missing before. And this matches down here as well. I am missing one more, and it almost makes me think there's a different, like a third X variable. And I know that I'm missing variables, so let's add one. And yeah, so this was a 16-bit value that I was missing. And what does our stack look like? Now our stack is actually matching. So I'm not upset about that. I still have these missing instructions above though, which means this is not getting pushed to the stack like I thought. Or so just looking at this assembly, what is this doing? Excuse me. Sorry about that. We're loading the pointer at this offset, which is a function. We're calling that pointer, we're loading that into register V0. We're calling the function that's stored in V0. We're taking the result, which gets written back to V0. So now what we've done up here is obliterated. We have a new V0. It's getting moved into V1. V1 is then getting pushed to the stack. V1 is immediately getting read back to the stack, but this time as A0. And then that A0 is being compared with index equal to -1. What is forcing this to the stack, though, is not clear. And it could be that I have some things on the stack currently that shouldn't be on the stack, and vice versa. Or sizes of some of these may be wrong. U and V being 32-bit is kind of funny. It's possible that these are 16. So maybe if I reduce the size of some of these, that will work out. There's a SEH instruction here, which makes me think that I don't have the right signature. Prim index. Let's find this. Prim index should be a 16-bit value, and this is 16-bit value. So I'm not sure why the SEH is necessary. We have the function signature. I'll get back. Let me see what the PlayStation says. PlayStation is liking that much more. Yeah, it almost seems like thank you, Dig Down Deep. I was a little late, but I appreciate it. It almost seems like the function signature here isn't being respected. It's being treated as a 32-bit value being returned. Oh no, it's this comparison that produces the sign extension. That shouldn't be necessary though either. And everywhere this is being used, it's so I'm gonna set it back to sign 32. That seems unnecessary. So I'm gonna do the painful conversion of variables. So the way that we determine what variables are correct or not for MetroWorks is variables effectively are assigned to an exclusive register, and we can go down through the whole function and see where those are assigned. They won't necessarily be assigned to the same thing that our code is producing, but we should be able to find the register that our code is using, and those should map one-to-one. So let's do that. So here we have S2. So everywhere, and we already see that it's it's failing. Everywhere. Let me find another case here. So we'll go S0, S0. There is this is around 9.8. So primbuff is temporarily being stored into S0, and then the result of the index addition is also being stored there. At the moment, there's nothing we can do about that, so I'm not too worried about these down here. What I am worried about is the rest of it. Every time we're using prim, are these the same? And that actually looks pretty good. Down here, however, that's not the case. We have some scenarios where those are being used differently, and it is possible in different cases that those variables wouldn't be assigned to those registers anymore. If there's too much register pressure, they'll get moved out to something else. And so at this point, we can't trust that S0 is being used for prim. So it doesn't always work, but often it can. So let's go down to 92. Let's see what's happening down here. This is another scenario where, here actually, it looks like there probably is a separate primitive that is being used instead of prim. So let's make a second prim. We already have one, but I'm just gonna make a prim 2 for this one. It might be something to do with the light, I don't know. But it does look like this is something separate. So as this is changing, what so now we have S3 and S6, and those are all being used the same again, and so it does appear like those were separate variables originally. So let's go back to S0 and see what we can find there. Those are all the same. Here it's being used in place of V1. There's not much that can be done there. Here on 128. This looks like, again, that prim2. And so prim2 is given a different register here, but that's okay. We actually have, oh no, never mind. Let's go back to S0. The rest of it looks pretty good so far. Okay, so S0 I think is mostly taken care of. Now we're going to move on to S1. And we'll see where S1 is being used and what our version is. So here it's V1. That probably means that we're loading this value on line 70, and that is going to a variable. This almost seems like, and it's not super important, but almost like self is being assigned to something else and then being read from. But I don't think that's, I think that's just how the code got generated. So we can't map it to V1. That is for sure. So let's find another case, and that's happening here as well. So it looks like S1 is often being used just as a temporary register in the original. So let's move on to S2. And S2 has the same treatment. Here S2 is being used the same. So we have our S2, it looks like, correct. Same there. Same there. And same. So S2 looks good. Wait, S3. S3 was, I believe, the prim2. So on 53. Oh, it's the same as last prim. So anywhere we have prim2, we can use last prim. I don't know which one I like better, but I'll just use last prim for now. And we need to get rid of that other declaration. All right, S4. S4 looks mostly the same so far. One difference down here. So let's go down to 193. Apologize for how uninteresting this may be, but it's necessary. This is kind of the grunt work of decompiling. So it looks like what is S1 down here ends up being S4 above, at least for a while. I'm not sure if it is possible that these are happening inline and then that they're not separate variables. So I'm going to leave it for now, and if nothing else fixes it, then we'll look at that again. S5 and S6 look like they may be transposed. And let's see what those were. We do have an S6 up here on 83. So that's position Y. And on 43, also position Y. What I think has happened is they're just out of order. Yep. And putting them in the correct order then fixes the registers they're assigned to. S6 we saw was the other one of that pair. And so those should mostly match up. I may have to look at this a little more closely. 211, 214. Yeah, so there's a bunch of temporary S5 and S6 are being used as temporary registers here. I don't think that they're under our control, so I don't think there's anything that can be done there. Just as the other registers get sorted out, those should as well. S7. Where's S7? There's S7. So we have a variable here on line 70, but not necessarily one. So let's look at that, line 70. So even though we have this offset, this offset Y is, yeah, it is being used. It's being pushed back to the stack in ours. So again, we have some variable in ours that doesn't exist. I'm gonna save this, check the PSP, or sorry, PlayStation 1. No, actually a little further away. Let's see what PlayStation 1 doesn't like. That same area, 6970. So it does tell us that there is something off here. T0 and A3 are swapped. Those are both just temporary registers. On the PlayStation side, we can't rely on what registers are being used as much because the optimizer just uses whatever's available. 118, there's a immediate difference that was missed. This should be EID 16. I'm not sure what... I'm going to just put a placeholder there that will air out later. Okay, so there is a out of order load down on 191. This was eventually... no, it's not. So in the PSP version, and this actually may lend itself to the idea that this is being pulled out as a... Or sorry, these are all inline. And the reason I say that is because in the original version, this array gets hoisted out of this loop. And that means it can rely just on the cache to pull that in. But in ours, it gets reloaded every time. And that may be because we're saying store this value in a register. So let's go through and do that work of getting rid of all these J's and replacing them just with calculating these indexes in line. And it's possible that that will be enough to hoist that global out. No, that didn't do it. I do want to see on the PSP side if that makes a difference. That's right. I intentionally broke the PSP. So on line 120, I can see what this is. It looks like I just had the wrong entity ID. So it should have been 22, not 24. I'm getting close. This one is definitely looked simpler than it ended up being, which is always kind of fun. So there is this masking of this external entity ID, and that's because create entity from entity takes a 32 or a 16-bit value, but it looks like it's undeclared. So we're gonna comment that out. We should get rid of that there, which works. We have this load immediate that's missing on just above it. That's happening out of order. Oh, I did look at that earlier. Yeah, unfortunately, there's also nothing that can be done there. Oh, can we load? Let's see. Yeah, let's do that. We're gonna load last prim and then set its value. And that gives us the instructions we need minus the move. Bummer. close, getting closer. Oops. Oops. It doesn't change the PlayStation version at all. Position X and position Y are not being initialized before being used on line 217. That is a good indication that I screwed something else up. Where? Here. It's just called X. That makes things worse. Position Y is not being used. That should be offset Y. It makes things much better. Much better. It's getting very close. PlayStation check. A little better. PlayStation doesn't care if your variables are uninitialized. GCC says, you know what you're doing. I trust you. You would never make a simple mistake like using an uninitialized variable. I'm going to give you all the power. We have some variables that look like they are just declared out of order. It's gross, but that fixes a bunch of those. A couple more. Let's move this down to see if that helps. No change. Let's move it down. It's really kind of gross that changing variable declaration order changes register allocation, but you work with what you got. Ah, this is getting so close. I can feel it. Not quite there. So these values still aren't getting hoisted. I do, let's look at the PSP. I want to see what that ended up looking like on the PSP if this code seems fine. The reason I originally put them into variables is because of this move to, or the store in S1. But it looks like S1 probably was just being used as a temporary register. It is possible that part of this gets moved out into a register. So it would have to be everything before the call to sign. So let's make it angle. We'll make it a 32-bit angle. See if that helps at all. So we need everything that's going to the sign call. Actually, the only thing going to the sign call is this value. But that might be enough. So it's getting stored on the stack, which isn't the worst thing. Pulling out all of... actually, I like this. I'm going to pull all these out. I like it because this may be more the GCC optimizers alley, getting this kind of off by itself. And it simplifies these lines a little bit. One of my favorite things, and I think this is the reason I like decompilation so much, I like re-implementing things. And so Mozilla was mentioning that he's wanting to re-implement Final Fight. And I really like the idea of like both white box and black box testing something, and then trying to re-implement it. And I've done that a lot. It's still not being pulled out. I was hoping that would do it. The only thing that may be preventing this is I know that this is a fixed 32. It's actually not a fixed 32. We can just treat this as a signed 32. Get rid of the val, and maybe that'll help, because now it's not a struct anymore. Well, anyway, I've always liked re-implementing stuff. There it is. That was it. I made it a fixed 32 because of how it was being used. Fixed 32 wasn't the right type anyway, because fixed 32 is a SOTN fixed, so 16-bit, 16-bit real number. This is being treated as a 2412 real number. Roaming says, I've been watching C++ talks about reflection coming to C++ 26, and I hope it makes modding decomped games earlier along with other cool stuff it brings. Definitely. Reflection is one of those things where I can't believe that it's taken so long. Probably my favorite production language is Objective-C. And Objective-C is like the most dynamic language, but then you can write C and make it super fast. And it had awesome reflection capabilities, probably 35 years ago. And the fact that C++ never got anything like that was crazy. And I know that there's performance costs and blah, 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 blah. And it's not something you want to do all the time. But when you need it, it is really great. It makes solving certain problems very nice, very nice. Love or hate Java, so I have some, I need to come through and fix up some of these constants that are wrong. The reflection in Java is not terrible, and I think a lot of the like point cutting and aspect oriented type programming that you can do, again, kind of makes certain problems easier that just would be hard to solve otherwise. I'm going to make a comment about this sign 32 that it's actually a PlayStation fixed. And let's see what the official name for that is in the docs. PlayStation format. Yeah, that is any kind of reflection or introspection is just so much easier. You can do duct typing much easier. I mean, I get, like, if possible, we want to call things at fixed offsets and cache the world and fast. But there's the programmer productivity part of it as well. All right, so I do need to fix these constants on 203. It looks like the mod, this is the one that I thought maybe like a mod 26. That doesn't seem right. Let's try 16. 16. I don't know why I came up with 32 earlier. So some register differences, still need to work those out. Getting close. I hate making stupid mistakes early on. You kind of choose something and say, this will make my life easier later on, and then it totally screws you over. All right. So we have register differences, and the PSP is still providing hints as to where variables might be different, but I think I'm going to leave it here for now. And I might not come back to this one on the stream. I think it's gotten far enough. The interesting problems have been solved. The remaining problems are bookkeeping, and hopefully those could be worked out. If I end up putting this in the permuter or anything like that, I'll do that on stream and go through that process because I think that's worth going over from time to time. But you've been watching Castlevania Symphony of the Night decompilation on Made Up of Wires. Go to soten.z.dev for more info. Some of the things we looked at were one of the Doppleganger 10 functions that's also used in Doppleganger 40 with some slight changes that we will need to figure out once that one is once this function is decompiled. See where those differences are. We talked a little bit about how the clock tower is rendered and how that can be changed now that we have all that code decompiled, and some of the things about the clock tower as well. And a plug for Game On Expo. I'll be there. There's still no schedule up, but I'll be there on Friday, April 5th at 7 p.m. One day it'll show that. As far as I know, that hasn't changed. But the exhibitor hall is closed. You can't do any more shopping. I did mention that at 7:30, my talk is going to go a little longer than 30 minutes, but at 7:30, Living Tombstone will be playing, and I hope to see them. And Family Jewels is going to be there sometime that day. I don't know when, but I actually hope to feature music from his cover of Bloody Tears in my talk as well, which is an incredible cover. If you haven't heard the Family Jewels cover of Bloody Tears, go check it out. Oh yeah, he seemed like a cool guy. I just emailed him kind of cold and said, hey, can I use your song? And he seemed cool, and he's like, yeah, I'm going to be there too. So I hope to meet him. Awesome. Well, anyway, yeah, thanks everybody. Thanks Mozilla. Thanks for roaming. Dig Down Deep. Project Omega, good to have you back. I'll see you all tomorrow. Adios.